This is section 2.6 on evaluating limits using absolute values. So what we need to do before we calculate limits is to remind ourselves what the absolute value function looks like. And an absolute value function is basically a piecewise function. We define the absolute value as positive x if x is greater than or equal to 0, and we define it as negative x if x is less than 0. So we see that the function is defined and changes at 0. So if we look at the point 0 on the graph, we know that if we rise 1 and run 1, we're going to get a positive slope, and it's going to be linear. And that's what this function represents, a positive slope. If we rise 1 and go left, we see that we have a negative slope, and that's why this is negative. And if you look at it and connect the points, because it's continuous, we see that we have that V shape that you're used to in 2200. So how do you calculate the limit? So by observation of the graph, we can see that if we look on the right side and we look on the left side of 0, we can see that the function is approaching 0. So how do we do it algebraically? We are going to check the left hand and right hand limit. So the limit as x approaches 0 on the right and the limit as x approaches 0 on the left. So let's write that down and see what we get. So the limit as x approaches 0 on the right, and this function, because I'm approaching the right, I'm going to use the positive slope. So this function becomes positive x. And if you plug in 0 into that function, we get 0. We're going to do the same thing as we approach 0 on the left. So what function am I using in the piecewise? I'm using negative x because we're looking at values that are less than 0. If you plug in 0 in for x, you get 0. And that's why the limit as x approaches 0 of the absolute value is equal to 0, because the left and the right hand limit are the same.